So homework 21, going to be working with systems of equations to solve some different kinds of word problems. The first one talks about being a value mixture problem. A lot of times it'll have to do with money and amounts, or in this case milliliters and amounts. But it says here 2 rainstorms occurred in 1 week in a certain area. In the first storm, 40 milliliters of rain fell per hour. In the second storm, 25 milliliters of rain fell per hour. The rain lasted for a total of 55 hours, resulting in a total rainfall of 1,825 milliliters. How long was each storm? So we're looking for how long the first storm lasted and how long the second storm lasted. One of our numbers in our problem on these types of problems is always going to be the total, like we had on those previous word problems. How long was each storm? Well, we know the rain lasted for 55 hours. That's the length of both of our storms. So one of our equations is going to be the length of the first storm plus the length of the second storm is going to be the how long, 55 hours total. The other one is coming, in this case, from the number of milliliters that fell for each hour. The first storm, 40 milliliters per hour fell, so if I took 40 times the number of hours of the first storm, I'd have the total rainfall. On the second storm, 25 milliliters of rain fell per hour. So if I take 25 times the length of the second storm, I'm going to have how many milliliters fell for the second storm. Tells us that the total number of milliliters for the 2 storms, 1,825. Now you can solve these 2 different ways, either by the addition method, which is the one I prefer, or by substitution. First one I'm going to do by the addition method, and then I'll do the second one by substitution, and then you can decide which way you like better. I want to find both the first and the second storm, so it really doesn't matter which variable I eliminate from my equation. I'm just going to go ahead and get rid of the f's. So I'm going to take everything in that top equation by a negative 40 so that I have opposites in front of my f's. So using my distributive property, I'm going to have negative 40f, negative 40s, and then I'm going to make sure I take that negative 40 times the 55 on the end. So if you grab your calculator and take negative 40 times 55 for me. Negative 2,200?
Yeah.
I now have opposites in front of my f's. My f's will cancel out. 25 minus 40 would give me 25 minus 40 is negative 15s. 1825 minus 2200.
Negative 375.
Negative 375. And then in order to solve that, we're just going to divide. Here we have a negative divided by a negative, which is going to give us a positive answer. Negative 375 divided by negative 15 is?
390. Wait.
25. So that means the storm lasted for the second storm lasted for 25 hours.
Correcting the name?
Yep.
Okay.
We want to find the length of the first storm also. It looks a whole lot easier to substitute into the top equation instead of the bottom one, so I would use the top equation. The first one plus the second one, it's 25, equals 55, right? Because I knew the sum of the 2 were 55. If I subtract my 25, the first one lasted for 30 hours. So look for, first of all, what the question asks, how long was each storm, and then see if somewhere in the word problem there's a total for those 2 values. So number 2 says 2 mechanics worked on a car. The first mechanic worked for 20 hours, the second mechanic worked for 15 hours. Together they charged a total of $3,950. What was the rate charged per hour by each mechanic if the sum of the two rates was $225 per hour? So what is the rate charged per hour by each mechanic? And right there they tell you the sum of my two rates is $225. So what's my equation going to be? How am I going to show the sum of my rates is $225? Sum means I'm going to add the rate of my first mechanic, which we don't know, we'll call F, plus the rate of my second mechanic, I'll call S. So F plus S is the total of the two rates, $225 per hour. Second equation going to have to do with how much money they're going to make. The first one worked for 20 hours. So if I take 20 times the rate he makes per hour, we're going to find out how much money he made. The second mechanic worked for 15 hours. So if we take 15 times the rate he gets per hour, we're going to find out how much money he made. Together they charged $3,950. Now we did the first one by the addition method. I'm going to do this one by the substitution method because some people like one way better than the other way, and we're all a little different. I'm going to go ahead and solve this equation for F. So I'm going to move the S to the other side. So I'm going to minus the S. So F is going to equal 225 minus S. So if I'm going to solve this by substitution, I'm now going to replace the F in this second equation with the 225 minus S. So I'm going to have 20 parentheses, 225 minus S, plus 15S equals 3950. So I've just replaced the F here like we did with the substitution method. So now I have to do my distributive property. If you grab your calculator, 20 times 225. 2,500 you said? 4,500? And then 20 times minus S then would be minus 20S. Plus 15S equals 3950. So combining my like terms, and just because I like my variables in front, negative 20 plus 15 would be negative 5S plus 4,500 equals 3950 then. So if I want to solve that for S, the next thing I got to do, subtract my 4,500. So negative 5S equals 500, or negative 550, right? And then I'm going to divide by negative 5. So S is going to equal 110. The second mechanic is charging $110 per hour. We still have to find the rate of the first mechanic. We're going to do that by substituting into this equation that we solved for F. F is going to equal 225 minus the second one, which was 110. And so if you subtract that, you get $115, right? So the first guy charged $115 an hour, the second one $110 an hour. Wish I made that. that's if you want to do it by the substitution method. You can pick whichever method you like better. All right, so number 3 on homework day 21 had a typo on it, so it wasn't working very well. That should have been 35 miles an hour up there for the fuel efficiency of the first car. So it says a family has 2 cars. The first car has a fuel efficiency of 35 miles per gallon of gas. The second one has a fuel efficiency of 30 miles per gallon of gas. During one particular week, the 2 cars went a combined total of 2,425 miles for a total gas consumption of 75 gallons of gas. The question says how many gallons were consumed by each of the 2 cars. So we know that on these types of problems, one of your equations is always going to come from adding your 2 unknowns together. It tells us that we're looking for how many gallons each of the cars used, and it told us the total gas consumption was 75 gallons. So one of our equations is that if you take the gas consumption from the first car plus the gas consumption of the second car, you're going to get 75 total gallons between the 2 cars. Our other equation has to do with the fuel efficiency, and if I go 35 miles per gallon and I used so many gallons of gas, that's going to tell me how many miles I drove. So the first car has a fuel efficiency of 35 miles per gallon, and we used F gallons of gas. The second car had a fuel efficiency of 30 miles per gallon, and we used S gallons of gas. Total number of miles the 2 cars went was the 2425. So after we set up our systems of equations on those, we said, oh, we got to eliminate one of our variables from our systems of equations, and that we could either do it by substitution or addition, and you guys seem to think that addition was the easier way, which is also what I think. You can either get rid of the F's or the S's. It doesn't matter. Which one would you prefer to get rid of on this one? The F, okay. If I'm going to get rid of the F, I'm going to multiply by the opposite of what's in front of the F, so I'm going to multiply everything in that top equation by negative 35 then. And then I'm going to use my distributive property. So negative 35 times F, the negative 35 times the S, and then we have to take negative 35 times 75. Multiply that again. 35 times 75. Ah. So negative 2625. Since I have a negative times a positive, I'm going to get a negative down there. Now that I have opposites in front of my F's, I can add my equations together. So the F's are going to cancel out. 30 minus 35 would give me negative 5S. 2425 minus 2625 would be a negative 200. And so in order to solve that, all we need to do is divide. If I divide by my negative 5, S is going to equal, I have a negative over a negative, so it should be positive, right? I hopefully don't have a negative 40 gallons of gas. My second car used 40 gallons of gas. I still want to find out how much the first car used. You could substitute it into either one of my original equations, but the top one's obviously easier. And so I'm going to say the first plus the 40, which is the second, is equal to 75. Then all we need to do is subtract to solve that. So the first one used 35 gallons of gas. So that's what that one was supposed to be, but I evidently can't read or type. One of the two, I messed up one of those numbers. So it should have been a 35 up there instead of the 24 that's on your paper. All right. Then we had to go all the way down to, it must have been number 11 where we left off.